going to talk about how to work with a normal distribution curve, sometimes called the bell curve. I would anticipate on the AP exam that this be referred to as a normal distribution. However, we're going to talk about how to apply some of the concepts regarding standard deviation to this curve. At some point this year, you will have to memorize the visual that I'm about to fill out. For at least the first portion of the year, though, I'll give you a hard copy of it. You can even copy it down into your concept map, and you'll have access to it as you answer some of the questions. But this is a distribution curve. Of course, the higher the curve goes, the more that score occurred in your distribution. The reason we call this a normal distribution curve is because the mean, the median, and the mode are all perfectly the same. So all of those central tendencies that we talked about in Unit 2 are all the same. So the mean, the median, and the mode, which would allow us to determine where all of those are located just by looking at this. Because again, this middle point, that high point, indicates the score that occurred the most. The mode, because we know the mean, median, and mode are all the same in a normal distribution curve, whatever this value happens to be is also the median and also the mean. When this occurs, it allows us to chunk out portions of the distribution curve and add percentages in each of these locations, indicating what percentage of scores fell into those ranges. And I'll show you what that means. So the values I'm about to put on here do not change. This column here to the left of the mean, median, and mode is 34%. That also occurs on the other side, because again, this is perfectly symmetrical. Do that a little bit bigger for you. So we get 34%. 34%. The next one over is 13%. And again, that applies on the other side because this is perfectly symmetrical. And then we have 2%. That again applies to the other side. And then finally, the smallest one is 0.2%. These values I didn't just make up out of thin air. They are going to occur no matter when you use this visual. So again, I'm going to provide you with a hard copy, copy it down into your concept map. You'll have it as a resource. Once you have this set up, answering the questions that you're going to encounter on the AP exam really just requires us using a couple different steps here. And I have those steps here. Input the mean. Typically what you're going to see is you're going to see a multiple choice question, and it's going to say something along the lines of this. On the IQ test, and this is a multiple choice question, the mean was 100, and the standard deviation, which I abbreviate SD, the standard deviation equaled 15. I picked those two numbers on purpose here. Virtually all major IQ tests are intentionally designed to produce those values, a mean of 100 and a standard deviation of 15. Typically, throughout really the entirety of using the concept of IQ, 100 has always meant average. So IQ tests in a modern context, and this has gone on for a while, are evaluated frequently in order to be adjusted so that the mean always is 100. That's sort of equating for the Flynn effect, which we talked about earlier this unit. But the first step here is to input the mean. And what I mean by that is to input it somewhere here on the x-axis. Now, where would the mean go? Is the mean over here, over here? Well, logically, we established that this high point, because with a normal distribution, the mean, median, mode is all the same. That means if you follow this all the way down, right below where I put the number 0 is the value 100. So if this is how the collection of students did on a test, and this is what it would look like if you administered an IQ test to a large population. So you have, your sample of people out of a giant population, you gave them an IQ test, your results would look like this distribution curve. Students that scored 100, this value would be here. That would likely be the highest value because IQ tests are designed this way, so the mean, median, mode are all the same. It allows you to conclude that a 100 be located right here under where I put the 0. And that's always the case. So if I said the IQ mean was 90, the 90 would go here. If I said it was 80, it would go here. It doesn't matter. The next is to input the standard deviation that I abbreviate SD. Now when you look at this, you might notice I have the numbers 1, 2, 3, -1, -2, and -3. Each of these values represent increments of whatever the standard deviation for your test happens to be. So in this case, the standard deviation is 15, which, as I alluded to, is the default for major IQ tests. Wechsler Adult Intelligence Scale, other general intelligence tests that exist out there. That's kind of the default in the industry, but 15. What that allows me to conclude is that each of these columns that I have these divisions with the numbers 1, 2, and 3, -1, -2, -3, mean that I can continue inputting numbers in increments of the standard deviation of 15, which means when I go here, that number 1 represents one standard deviation, which in this case would mean that this number here would be 115. So I took 100 and I added 15. Then I could actually continue that to the following. I could go from 1 to 2, and I would put a 130, again 15, and then the final one would be over here, 145. So in increments of 15. Opposite is true going backwards. So here we're going to have 85, we're going to have 70, and we're going to have 55. I just went in increments of 15, starting in the middle. Plus 15, plus 15, plus 15. And then the reason they're -1, -2, -3 is because obviously you're going to go in the opposite direction. What this tells me is a few different things. You could see a question, right? That after establishing these two standards, it then says, what percentage of students scored between 85 and 115? How are you going to answer that? Well, it's actually pretty simple. You look at this visual, you find the number 85, which is right here. You find the number 115, which is from here to here. You then follow up into the columns, and you add the two values together. The values in this visual never, ever change. The value there would be 34 and 34. So the answer to this question would be 68. If I asked you how many students scored between 70 and 130, so now we're bracketing this out a little bit further. So now we're going to go 70 to 130. Well, it's going to be 34, 34, 13 and 13. That's 26 plus 68. There are technically some decimals in this. The answer that you would see after you equate to some of the decimals that I'm not including in the visual there is 95. If I were to extend that out even more, I could go from 145 to 55. 145. Now you're getting basically 99% because you're adding 2, 2, 13, 13, 34, 34, and you're basically getting 99%. That's one of the common questions that you could ask. And you could see this in a few different ways. How many students scored between 70 and 85? Well, you go up 13. How many students scored between 100 and 115? You go up 34. Now, there are a few different types of questions that you could encounter. One of which, and it can be confusing how this is worded, you might also see them ask, what percentage of students scored one standard deviation above and one standard deviation below the mean? That is a different way of asking how many students scored between 85 and 115. Because when you look at this visual, one standard deviation above the mean means this column, that's one increment. One standard deviation below the mean means the column to the left of the mean. If that question were asked, it's essentially asking you how many students scored one above and one below, which would require you to add both of these 34s. Occasionally I'll have students that look at that question and they'll interpret it in a manner where they say, okay, that's 34. Nope, that's not what it's asking. Make sure if you see that question, it's actually 68. Alternatively, the other type of question that you can encounter, and I'm going to put in new numbers here just so that we can see it in a different manner. So I'm going to come up with a different set of scores. So I'm going to erase the 100 mean, 15 standard deviation, because although that is the default of IQ tests, you might see a question that's a little bit different. So what if we're not going to talk about an IQ test? We're going to talk about a math test. And a teacher, for whatever reason, wanted to do this. So they did a math test. The mean was a 90, and the teacher found out that the standard deviation was a 4, and you were told that it's a normal distribution, so it fits this perfect symmetrical curve. Well, the same standard applies. Step 1, take the 90, find the middle point, put it right below the 0. Look at the standard deviation of a 4, go in increments of that. One standard deviation above, 94, another 4 is a 98. For whatever reason, this test was worth more than 100 points, so we'll go all the way up to 102, and then we'll go down. Minus 4 is an 86, an 82, and then a 78. So again, very simple standard applies to how to fill this out. One of the types of questions that you could see is, which score falls one above and one below. And when you see this question, what it is asking is, of the 5 options that they give you, which fell within this region of one above and one below. So you might see the options of like 72, 99, 92, 80, and 82, right? Those are your 5 options. Well, 72 is way over here. That doesn't fit within here. 99, nope, that's too high. 92, perfectly right here. Yep, that's going to be our answer. 80, that's too low. 82 is also too low. So that's another way of asking you to work with this graph, asking you which of the values that they've provided fell within this range. So sometimes they ask what's the percentage, sometimes they ask which number falls into that range. So there's a few ways that you need to be able to handle working with this visual. The last thing to note, and there'll be plenty of practice questions that we'll do both in class and over the course of the remainder of the year with this. But the last thing to note, and they haven't really done this too frequently, but occasionally they will, and it's honestly really quite simple, so I will mention it. It won't take long to talk about. You can utilize this visual to talk about percentiles also. So let's say it's a normal IQ test, which again is a mean of 100 and a standard deviation of 15. That's the standard for all major IQ tests out there right now. So I'll fill it out back to the original numbers that I input under each of these before. So 55, 70, and so on. Occasionally, you'll see a question and it's something like, what score was on the 84th percentile? Well, that's actually pretty easy to look at. Basically, you just keep adding these up until you get to 84, and they usually pick nice, easy numbers to work with. Well, a quick way of looking at that is, well, if this is the mean, median, and mode, and this is perfectly symmetrical, this middle point here represents 50%, because the whole thing together equals 100. So from here to here is 50. From here to here is another 34. Well, 50 plus 34 equals 84. And again, they'll pick easy numbers to work with. The 84th percentile is this column right here, which would mean 115 is on the 84th percentile. So that word percentile is just a way of them asking about grouping together large amounts of these. If they ask, what score is on the 50th percentile? Well, it's 100. If they ask, what score is on the 16th percentile? That would be all of this. It would be an 85. If they ask, what score is on the 2 percentile? Well, that's a 70. If they ask, what score is on the 98th or 99th percentile? Well, you add all of it up and it would be something up in the 140s. So that word percentile is basically just a way of asking you about including some of the values in between each of these columns together until you sort of equal that amount.